days, well, probably I will be corrected quite a lot because I don't really know. I never touch. I don't know. I hope I get out of this session today knowing what is GraphQL, what can you do with that today, and what is exactly schema stitching with ASP.NET Core, which sounds quite interesting. That's probably why we're here, but our speakers will tell us that about. I'd like to thank first to Michael and his brothers. I call them the capsaicin brothers. They are, you can recognize them by a picanto or pepper, hot pepper in their shirts. They will be there for you. And also a big thanks today to Swiss Life. I mean, this amazing room. We should do more events here. Who would like to do more events here? Yeah. Oh, yeah. Well, hope you raise your hands later. So thank you very much to them first and to Swiss Life. So I would like you to give a big thank you to them. We have drinks outside. There will be food. There is food. There will be food later, hopefully. And, well, quite interesting conversation today. But first, who are we? Who is the first time that has come to a session of the .NET user group?
In Zurich.
So in Zurich?
Yeah, was in other user groups. But...
Yeah, in Zurich, yes. Well, usually we do events in Zurich. That's why we have the... Let's see if it works. Yeah, nice. Zurich, there. That's nice. I like it. Oh, no, wrong button. And also thanks for offering solutions for Tech Tour, also to where we usually do events in, Impact Hub, Stanford Group, and well, we are also partnering with other user groups like Xamarin, Azure, other events like .NET AI Switzerland and Swiss Angular, because we have one Angular lover or more than one in the group. And what do we do? Oops. This should be, it's a Mac. Yeah. So basically, what do we do? We do events for developers, from developers to share knowledge, create excitement, networking included. Today, even we will have some maybe picantos in there. Maybe not the ones we can eat, but it's going to be definitely hot event, I think. And beer and pizza or some food. In this case, there's quite good guacamole outside. Who is doing this? Well, I founded the group in 2013 together with a friend, and then we became more people in there. Like Powell, he was the one organizing this event today. Also, we have Nigel, we have Logan, we have Fabian, he's quite active in the community, and Muller. Probably you know them already, they're quite fond of public speaking as well. They're good people, I like them. We do events regularly, usually one a month, sometimes two. Quality talks, speakers, content. We usually either have a sponsor to put that, or we bring that, sorry, from some sponsoring money, and the main idea is to learn while sharing good moments, and for free, of course, right? If you paid for coming here, sorry, hopefully never got paid for coming here, because this is quite free. And what can you do? You can follow us on Twitter, .NET Zurich, join our meetup group, hopefully you did already, and tell your peers, help us grow in members. I mean, next time we are doing something here, I would like to see a full room here. I think how many people fit here? Like
170?
170. Wow. That's cool. 70, nice.
Yeah,
it's quite cool. I like it. And also, if somebody here knows something interesting, please come to me or any of the persons that I showed before and let us know. We are looking for speakers. At the moment, we are a bit booked out until this end of year, so that's a good thing. But for next year, we still have speaking slots. There's nothing settled. Or even if you have a topic you would like to give a short talk, like 10, 20, 30, 40 minutes, just come and propose. And that's it. We want you for delivering short lectures or long ones, up to how do you feel confident. And again, special thanks to Swiss Life. Thank you very much for having us here. And I give the word here to Michael.
Yeah, just switch over.
Yep.
Let's get rid of this one. And here.
And by the way, if you haven't silenced the phones, do that now.
So, good evening, everybody. Guten Abend. Welcome to our meetup here at Swiss Life. It's nice to see that so many people are interested in GraphQL. It's not so famous in the .NET space, I think, but that's gonna change, hopefully. My name is Philip. I'm a developer here at Swiss Life, developer/architect, working on the customer-facing portal. Have a quick look at the agenda. You see we will have some introduction to our data fetching challenges, a bit to our microservice introduction, but mostly we will talk about GraphQL. We'll have a short Q&A at the end, but of course we'll have time there will be some beer later as well, so don't worry, with a beer to talk other things. So why we are here today? We're in Swiss Life talking about GraphQL. Some people think we just write stored procedures here. That's not true. So there's a bit of a story behind this. So there was I would say 2 years ago when Swiss Life decided to build a new customer-facing portal. And some of you know we have already a portal working. We built this 5 years ago. We did a lot of stored procedures. There was ASP.NET, not ASP.NET, ASP.NET, Razor, jQuery, Knockout, SQL Server, all that stuff we did at these times. So we thought it's time to kind of refresh our technology stack. So what we did, we sit in the container for 4 days and tried out all new technologies. So there was a lot on our list. It was Docker, Kubernetes, GraphQL, Node, there's all things like that. So after 4 days, GraphQL was on the list. After 4 days, we came out of this container. We had a working prototype, which was actually, we were quite happy with it, but there were some caveats which was not totally happy, I would say. That the first we wrote the backend for front end in Node because the GraphQL worked very well with Node, but we are all .NET developers. Who wants to write backend code in JavaScript? Maybe some do. And the other thing is we used GraphQL only in the backend for front end, but not in the microservices. So we went out a bit, looked what options we have to do it in .NET. We found a library, GraphQL.NET, which is also quite famous and I think a nice open source project, but there were some, core concept we couldn't accept. So there was the time where Michael just say, okay, then I build a new GraphQL library. He's crazy enough to do that. After some months, he came with his open source project and we started to integrate it in our microservice architecture. So we used the really early bits, beta alpha versions, but now I would say from here, 1.5 year later, this is where we are. So, and that's why we talk about GraphQL today. Michael? Sorry, it's Stefan. Always. Sorry about that.
So, hello everyone, and welcome here in Zurich Binz, here at Meetup at Swiss Life. My name is Stefan, I'm a full stack developer, and I want to tell you something about data fetching challenges in a modern software app. So, what are we doing here at Swiss Life? Next to organizing awesome meetups, we are developing a Swiss Life customer portal, which is currently a work in progress. And to give you a short overview, we prepared a video and I want to show it. So once a customer is logged in, he will land on this start page and he will have an overview of his contracts, in this case 3. He can navigate to another page and get even more information, some charts, and down below you will see all of his contracts. Once he navigates by clicking on a contract to a new page, he will land here and you will get even more specific data for this contract you clicked. Let's stay in this view and analyze it a bit. What do we see it here? What we see is a typical contract page in this new customer portal. And a page can consist of several components. In our case, we have 3 ones. On top, we have the chart component, and down below, we have 2 other. And each component requires its own data. So on top, we need some data points, and down below, we have some names and so on. Let's switch to a more data-driven view. As already mentioned, on top, we have this chart component with some data like contract ID and data points to draw the chart. Down on the left side, the benefits component, again, some contract ID, yearly pension. And the last one is the summary component. Also, we have here this contract ID, again, a product name and stakeholder and so on. So let's come to the first challenge we experienced, mutable requests. So let's imagine we have this chart component, again, with this data it needs. And the data will be provided by a REST endpoint. We can call it by using a customer ID. And this REST endpoint responds with contract ID and product name. So at the moment, data points are missing. That's why data points are provided by a second REST endpoint. So we have to call this endpoint again by using the contract ID, and we will get the data points. So as you can see, for this small chart component, we have already 2 requests to the backend to get all the data we need. So what if we could fetch all in just a single request? Let's answer this question later. The second challenge is overfetching. What is overfetching? Overfetching is when we get more data from the backend than actually requested by the client. So to have an example, we use this benefits component, and we have again a REST endpoint. We call it with an ID, and this REST endpoint responds with this big block of data. But what do we actually need from this big block? Only these 3 fields, so the rest is obsolete. We don't need it in this component. We have an overfetching. What if we could get just the data that we need? That's the second question we will answer today. So at this point, we have some kind of wish list. What we want now is a magic endpoint. And we can call this by using one request with all the data we need for all 3 components. And this magic endpoint answers with exactly the data we requested, without any over or under fetching. So what if we just get what we need in just one call? I hope Michael can explain.
Pardon?
Desktop recording.
I already started it. Yeah, hi everyone. I'm Michael Stipe. I'm an external consultant working at Swiss Life, and I'm working together with Philip in the Common Services team. So today we learn a lot about GraphQL on .NET, and the question that let me start again. So most of the time we go to .NET developers and ask them, do you know GraphQL.NET? They most of the times look very strange and think maybe, are you talking about OData? And GraphQL is something completely different. So what is GraphQL actually? GraphQL is a query language for your APIs and a runtime to execute those queries. And GraphQL was built by Facebook, and they built it in order to create a more efficient way to fetch data for their mobile applications. In 2015, Facebook open sourced GraphQL as a specification document, which was heavily adopted by the open source community, and companies like Netflix, Twitter, even GitHub or the New York Times, and many, many more. So let's have a look what GraphQL is. And I don't like a lot of slides, so I like more demos. So today you will get a lot of demos. So in order to get you into GraphQL, I have a little exercise for us. So I hope you all know Star Wars, because otherwise you will get lost. Let's fetch all the characters that appeared in Star Wars movies together with Luke Skywalker. It's an easy enough task. We just want a list of names, and that should be easy to do. So there is an API, a public API that is called swappy.co. It's a Star Wars API, and it is a REST API that is commonly used to teach REST. So swappy.co is basically a well-formed REST API. And we backend developers, we know REST. So we immediately, if we go on that site, swappy.co here, if you want to try it out, we know how to navigate it. The root documentation here of swappy.co tells us what endpoints are available to us. Like we have a people endpoint representing the characters. We have a planets endpoint. Some planets, we don't need that. We have a films endpoint to fetch movies, and some other endpoints that we also not need for our little exercise. So when we want to explore that, we can just do a fetch, like on the people's endpoint. I prepared that just in case our internet connection is not that well. And if I fetch the people's endpoint, I'll get, I would say what I would assume here, a list of people or characters. It's actually characters. And I have a Luke Skywalker character here, or a 3CPO, and so on. So that's easy enough. And I can assume if I put an ID, if I append an ID to my endpoint, that I can fetch a specific object. So that's basically how CRUD works with REST. We know that. So let's explore our character object here a little bit more. So it's JSON, and we know how to read JSON. So we can see it has a lot of properties, like it has a name, Luke Skywalker, and it has other properties. And also we have here an array called films. And we would need that because we want to fetch all the characters that appear together with Luke Skywalker. So the movies array here consists of the URIs, which basically represent references to our films resource. We could follow that along, and we would get the films object then. And again, if we look at the JSON object here, we can see it has a characters array. And the characters array, again, consists of a lot of references there. So we could follow them along and collect the data that we need to fetch all the names. So Stefan before said there's this underfetching problem. And actually, each time we have a reference, we are underfetching. Because it means we are fetching Luke Skywalker, and then we have to fetch another object. Because it's not the data that we actually need is not included in the first fetch. Okay. And this demo is the only JavaScript demo, so bear with me. I wrote a little program that implements the algorithms that I described, and it does it with GraphQL and with REST. Let's have a look at the REST code first. So this is a little function, fetch with REST, and it basically does what I explained further. We are fetching the Luke Skywalker endpoint here. Then we get the Luke Skywalker data, we iterate over the movies. Then we fetch each movie, we iterate over the characters, and then we fetch each character. And then we do a little data massaging, basically pushing it to an array and then just extracting the name. So that's easy enough. Let's see how that actually performs. So I have here the network tab. Let's clear it, maybe refresh it, I don't know. So clear it, and then we start fetching with REST. So it takes, yeah, we can see there are network connections coming in. The internet connection is here not that good, I have to say, But that's actually the problem Facebook did face with their first mobile application. So we can see it's turning out at 13 seconds, our little task. And at home, with a good internet connection, you will get 3 seconds, something about that. So, and we can see that we have like, you won't see that, but it says 62 requests to fetch just the names. And the problem here is also we had to fetch quite a lot of bytes. You can see 730 bytes, and it goes on. Because we fetched all the data that we don't need just to get the names. Okay, so let's have a look at how we would do that with GraphQL. I have rebuilt the API, the Star Wars API with GraphQL. And actually, in this example, we will use the Star Wars REST API in the backend and translate it to GraphQL on the fly. And let's see how that performs. So I will use for this task a tool called Playground. I hope you can see. The font is bigger than it appears. Okay, so Playground is a graphical. It's based on GraphQL, and GraphQL is a tool to explore GraphQL endpoints. On the left-hand side, I can type in my query. On the right-hand side, I will get the results once I push play. And then I have a button that is called Docs, which reveals the schema. I can now explore what my API offers. So I have a characters endpoint here. And when I click on it, I get the type which is returned. So the characters field returns a characters object. And we can see that we have similar data to our REST endpoint. I have like a name here that is string, and I have other attributes here, and I have a movies array. But instead of an array of references like we had before, I have an array of movies. And I can go on and explore my movie object here by clicking on character, for instance. And then I get the characters object again. So it's very easy to explore a GraphQL endpoint. And before I do my first request, I can already get a sense of the data. Okay, so let's write some GraphQL queries. And I hope everything works. So in GraphQL, I start my queries with a keyword, or my request with a keyword indicating what I want to do. I'm writing here a query. That means I want to read data. And then I do some squiggles to open my first request. And because I have something like introspection, that's the way I can explore my API, I can already see what I can do here. So Playground will offer me the available fields at this level to me. So I can pick one, like characters, and Playground already hints me there's a field ID I have to fill in. We remembered it, it's 1, because it's Luke Skywalker. And then I can go on and explore what I can do next. So I can fetch the name here. So let's just run that. Fetch the name of Luke Skywalker. I get it back. And that's the first striking thing you see with GraphQL. I specified what I want, and on the right-hand side, I get the response, and the response has almost the shape of my request, and that's by design. And as I change my query, my response will also change. Like, let's fetch some movies where Luke Skywalker appeared in. So that puts me as a consumer of an API in the driver's seat, because I can choose what data I want, and the server will give it back. Will give exactly that data back to me. And I'll give you an analogy how you can think about it. It's wrong, but it's good to start with. If you look at the query, it looks like an empty JSON graph. And you could think about it, you're sending an empty JSON graph to your server, and the server just fills it up. It is wrong when you get deeper into GraphQL, but it's a good way to start thinking about how GraphQL works. Okay, so our task was we want just the names of all the characters that appeared with Luke Skywalker. So let's get rid of the name of our Luke Skywalker character, and then we basically fetch Luke Skywalker, then we get all the films that Luke Skywalker appeared in, and then we get the characters that actually appeared in those movies. So let's do that. Play. And we get exactly this data. And did you see how fast that was? Although we are fetching in the backend from the original API. So we didn't just rebuild the API, we are using the slow Star Wars API that took actually 35 seconds. So let's benchmark that a little bit. It's an unscientific benchmark though. We fire and it's 149 milliseconds, but let's do it again, because actually it's a lot faster, because the actual request takes only 54 milliseconds. It's difficult to see on that pane, because the overhead was for the options request, so the course request for our server. So that's a lot faster than our REST API. And this is due to network connections. Network sucks, and GraphQL helps you avoiding a lot of network connections. And why is this GraphQL API so fast, although it pulls the data from our REST API? Because the GraphQL API is hosted in the cloud, and there we have unlimited bandwidth. So we can access this REST API with a higher bandwidth and pull the data in. Okay, so that was the first demo, the last JavaScript demo. Let's compare GraphQL to REST a bit. So with GraphQL, I am the user of the API is put in the driver's seat. So you as a user of the API can define what you want, and you get exactly that. Query and response closely align, and that's very important. With REST, you can also do very dynamic endpoints. I don't refute that idea. You could do very dynamic endpoints that are for each special case, but then you would end up with something like this. It's from the Amazon Web Shop API, and it has a lot of attributes. So these REST APIs get very confusing. And if you look at the attributes that we have to provide, I don't think that all of you would guess the right data types for each of them. And you might do a lot of errors by providing the data here. So with REST, it's more a try and error approach, where you try something out and hope it goes according to plan. So what is GraphQL? GraphQL avoids over or underfetching. So you basically don't have over or underfetching, because you tell the API what you want, and the GraphQL query engine will fulfill that. In GraphQL, you can do everything in one request. GraphQL is built on a strong type system, and we see that in later demos even more what that means. That means you can have awesome tooling like Playground. You basically can compile your queries, and you can deploy your service requests with the same confidence like when you are deploying a C# program, because you can compile it. That makes GraphQL very simple to use. And in GraphQL, you just have one endpoint. And that, again, makes it much easier than with REST. With REST, I basically have to know all the endpoints for all my resources. In GraphQL, we don't have any versioning. So GraphQL has a concept of deprecation. That means you can say this field is no longer supported, but still works. And versioning is one of the very complex stuff with REST APIs. And you get a lot of documentation for free, because due to the type system that you have, you get all the type information that I could explore without writing any extra documentation code like what you do with Swagger or stuff. Okay. And that makes GraphQL APIs very predictable. Okay, let's explore GraphQL on .NET a bit further. So I have not prepared really, but I have a little demo. That's demo number 2. Let's do a little Hello World example to get you all started with GraphQL on .NET. So we open Visual Studio Code. If it opens, should. Yeah. It's always nice if it doesn't work. Let's do it again. It opens up. Okay. So this is basically an empty ASP.NET Web API. There's nothing special in, except I have put the HotChocolate ASP.NET Core package in there. And that's the first thing you have to do. Okay, let me just click that away. And now we go to this startup class. So the thing with which you have to start in GraphQL is always the schema. You have to build up a schema. And the one thing a schema has to have is a query root type. So let's type up a simple class that represents our query type. So let's call it class query. We could call it whatever you want, but it's convention to call it query or query root. And let's give it a little method called hello and give it a response. And that's it. That's a valid query type. So now let's add to our service a little schema. Add GraphQL. And we have something that is called the schema builder. So I can say schema builder.new. And this really helps building that complex schema object. We can say add query type. Then we just say, okay, add my query here. Create my schema, and we are done with building our schema. The next thing we need is something to execute on our schema, and that is a standard standard ASP.NET Core middleware. So we say app, use GraphQL, and we are done. So let's fire that up. .NET watch, because we will change it in a minute, and say run. It's starting. Okay, it's up. So let's switch the tools. Okay, this is also a GraphQL tool that is built by us. And let's explore our API here. Let's first refresh the schema. It's there. Okay. And then see what the endpoint offers. And we get what we expect. We have basically a hello field here. All the underscore fields are internal fields to explore your types. Okay, let's fire that, and we get Word. That's fantastic. It's just a simple example here, but I always like to start with the hello world because you see how easy you can get started. Sorry. Okay, let's go back and explore it a bit further. Because actually, if we looked at the type, we see that the hello field is a string type. And in GraphQL, we have the concept of non-nullability. We now have it also in C#, but in GraphQL, it's actually enforced, not like in C# where it's just metadata. In order to provide those type metadata, there is an object called schema types that we can use to describe our types. So let's write a schema type, and in this case, it's actually an object type. So let's do that. So we say class query type, and then we say object type. Oh, I always do the same mistake. Okay, let's import that. Okay, and instead of adding our query, our native .NET type there, we're adding our query type now there. And at the moment, the program is basically unchanged. It's the same as before, because the object type would infer the same thing like the schema builder did before. But we can override now. Override the configure method here. And then we get access to our type descriptor. And the type descriptor allows us to give the schema more information about our types. So we could say the hello field is actually a non-null string type. Okay. Okay, and now our schema will change. Our schema will tell us now that we have a non-null type. But actually, if we execute our program, it will execute the same as before. But now comes a core concept that makes it very different to things like Swagger. In Swagger, types are basically just metadata. So you're telling someone that your schema behaves that way, but it doesn't behave that way. In GraphQL, we have an actual query engine that enforces this. So if I would now, I'm always using the wrong one, if I would now violate my schema in saying it's null, it recompiles, just give it a second, and then execute it again, I would actually get an error. So the execution engine will protect the consumer from consuming null on non-null fields. And this goes even further with GraphQL because you can have partial results. Let's say you have a huge query there and some fields violate rules. All those violating fields will be removed. And this ensures that you can, for instance, write TypeScript code where you completely get rid of the null checks because the server will never violate the non-null contract with you. And that's important. It saves a lot of code. Okay, let's move on. We have too much demos. So it's always important to look at what GraphQL is not. So before we go deeper into GraphQL, let's see what it's not and where we should not use it. So GraphQL is not a graph database query language. It sometimes appears like that. If you read GraphQL or GQL, you think maybe it's something with graphs and queries, so graph database maybe. But it's not. It has nothing to do with that. It's not a good solution for binary streams. So if you're Netflix, then you wouldn't stream your movies over GraphQL. You would use better protocols for that. GraphQL is not Facebook's version of OData, and it has nothing to do with OData, and it will not replace OData. OData has its own right to exist. GraphQL is not bound to a specific data source. You can use it with everything. So your data source can be a REST service, it can be a database, it can be anything. And it's not limited to HTTP, and that's very important because Facebook specifies in their specification that GraphQL is transport agnostic. You can use it over TCP, and with the next version of HotChocolate, we are allowing it to be used over gRPC, and we actually today allow it over WebSockets, for instance, or HTTP. So it's completely transport agnostic. And it's not limited to the JavaScript world, and that's a common misunderstanding because many people think it's a Node thing or it's a JavaScript thing, but actually Facebook built it for their native mobile applications first because there they had the problem of bandwidth and efficiency. And it might not be a good solution for a simple health check. So if you just have something like are you living server, then you should maybe stick to a simple HTTP call with REST. Okay, let's compare the GraphQL operations a bit to REST. We have query, and we saw what query is. It's basically reading from your server. And reading in GraphQL means you're reading side effect free on the server data. each field in GraphQL is executed in parallel. That makes fetching data super fast. Then we can mutate our server state, and that's a mutation in GraphQL. In REST, you never know. Sometimes it's put, post. I never figured out when to use which. Or it's patch, delete, you name it. And also, and that's important, we see that in a minute, GraphQL is real time. So that means in GraphQL you can write queries and tell the server every time send me the data in that exact shape when something changes on the server or in my other environments. And that is super important, because if you're using Twitter or Facebook, the updating counts, for instance, they are done through subscriptions, because all of Twitter and Facebook is driven by GraphQL. Okay, let's have another demo and have a look into operations. Switch over here. Go out there. 3.net run. Star Wars. Okay, just a second. I have to kill my other server. Okay. So this is another Star Wars example. In the first Star Wars example, we could just read some characters. In this Star Wars example, I added some more functionality so we can change the server state. So let me switch over here. Let's refetch the schema, and let's go on. So if we want to write a mutation can be written like a query. We started just with the keyword mutation. Now the server knows we want to change something in the server, and this means the execution algorithms of GraphQL actually change. I explain that in a second. So let's have a look at what we can do with the server. We can write reviews for our little Star Wars movies. I can say, I want to write a review here for the episode, let's Empire Strikes Back, for instance, and let's do a review and some commentary here, like maybe good movie, and then give it some stars, like 5. Okay, let me format that. Did I do something? Wow, yeah, I see. And did you see? The tool just told me with some squiggles it's wrong, and it would prevent me from sending that query to the server. And the server wouldn't even look at the query twice, it would just say it's wrong and would not execute on it. Okay, then reselect something, and there's an important aspect in GraphQL. Just the top level is actually the mutation. So this is the part where we execute changes. Everything beneath our mutation level is actually already a selection on the mutated state of the server. That lets me, with complex mutations where you change some references of stuff, reselect the data for my client application. So let's fire that up. Okay, it's fair enough. We write something to the server and we get the same back. It's not very interesting, but that would be how mutations work. Let's make that more advanced. Let me copy that, paste that here, and do some subscriptions. So subscriptions work the same way like mutations and queries. I tell the server I want to do a subscription, and let's do a subscription on the reviews. It's the only thing I can do. And we subscribe to reviews on New Hope. So every time New Hope is, there's a new review for New Hope, I want to get the star count because I have some analytics and I want to collect the stars that New Hope gets in a day. So I fire that up and nothing happens. There's just a spinner of death, and we're waiting for something to happen on the server actually. Okay, let me go back to my other tab here, and we fire events. But we are firing actually, or we are mutating on Empire Strikes Back. That means nothing happens here. But as soon as we change that to New Hope and fire it up, I already have my data here. And that's super impressive because you can have complete new application scenarios with that. And you can write very complex queries here because only the top one is actually the event. And once the server receives the event, it will query the system, prepare the data, and ship it to the consumer. Okay, so that is operations. Let's go back to our slides and move on. We have a lot more. 10, okay. Oh, 10 for this, that is not enough. Okay, but we also have problems in GraphQL. There's a problem called n+1, and that's the first you run into. Let's have a look at what it is. So let's assume we built the new Twitter, and we have a query that fetches all the messages. And we are not only fetching the messages, we want also to fetch the creator of this message. So because GraphQL is executed in parallel, we are fetching the messages, and then in parallel, fetch from the database all the users. And that can't be good because it doesn't scale. We would have thousands of connections in the case of Twitter to our database to fetch this user. So how do we solve it? Facebook invented something that they called preparable in the early days. And a preparable was something where the resolver, the code that actually fetched the user in this case, would tell the query engine, I want to have a user with this ID. And that was a prepare case. And then once all the resolvers that wanted to fetch some data did the prepare, they would then trigger a dispatch and gather the data. When Facebook standardized it, they introduced it as data loaders. And data loaders are basically their preparables, a bit more refined. So the resolvers basically call the data loader instead of their repository directly. And the data loader will then look in its request cache if in this request this particular item was already resolved, then it will immediately be dispatched to the server. Otherwise, the execution engine will gather all the requests and batch it in one request to the database. Sounds complex, but it's not. Let's have a look. So head over here. Let's kill our server. Die. Ah yeah, I have the subscription running. That's why it takes a bit longer to die. Okay. Let's go for data loaders. Okay, so we have our message type you saw before, and we have our object type class here already set up. And we have naively implemented the created by. So we get a service here that is a user repository in this case. We fetch that, and then we fetch from the user repository the data, basically the user ID that's requested. And this, we already discovered, wouldn't scale. So in order to fix that, I'm copying it in so we get to our snacks in time. So let me do that. Just a second. Paste. So we are still using our user repository here, but instead we are not doing the fetch on our own. We are telling the batch data loader that we can request from the resolver context that we have a resolver that we call user by ID here, and we tell it take this method of our repository, and we are actually fetching in this demo from Mongo here, and we basically tell it that this is a batch fetch on Mongo then, and here we tell the data loader that it should use this batch fetch method on our repository to get the data. And then we do the actual fetch in our resolver. And this is data loader load and load me this ID. And this is doing basically the prepare step on our API. So the data loader will then immediately return us a task that is awaitable. And so our execution engine has a valid execution on the resolver then, and this resolver waits until the execution engine decides to get the data, because it has decided that there are enough resolvers to call this message, call this data loader. And that is easy enough. So this would work. We can fire it up. Just a second. Yes, there. Oh, no, that was wrong. Because we're going to change it. Okay. So we go back in our GraphQL API here, we fetch the schema, and let's write a little query here to fetch the messages. So we are fetching the text of the message, and because we can, we fetch the username. Okay, that's super fast. But now, if we were to build Twitter here, I can see that we are actually fetching all the messages from our system. So that's kind of inefficient. Our server would actually die if we had the amount of messages that Twitter has. So there's a concept that Facebook introduced, which is called cursor-based paging. And we have implemented that in GraphQL. And I can show you how to use it. So basically, we have here our message resolver that fetches all the messages from our repository. And we do that through Mongo, and Mongo basically gives us a queryable here. So in order to let this data page, we can use a paging middleware. So on each field, each resolver field is actually a resolver pipeline that consists of as many middlewares as you want. So I can tell my field here that it now should use the paging middleware to fetch the data, and that not only changes the execution but also the complete the field shape. We see that in a second. Let's refetch. Yeah, and the banana cake pop tells us here that actually there's something wrong. And we can explore why, because we have a lot more arguments and different types. What I can now do is just tell my query, okay, let's fetch the first two. And then we have something that is called edges. And edges are basically, in my graph, not the leaf nodes, but my nodes where I can navigate. And an edge has a cursor, and the cursor is the position in my data set. And it doesn't mean how it's sorted. So the cursor is more stable than a position. So if I would have like sorting on top of it and add data while I'm paging through my stuff, it wouldn't mess up my order. So that's why when you're actually browsing through Facebook, you don't have jumps when new stories come in. So then I have a field called node, and that's my actual message that I had before, so I can fetch the text here. Let's fetch that again. So we now get a cursor that looks very complex. It's basically some data that describes the data set and where we are located. And we have the message here, which is our actual content. And the cool thing is that I can really slice my data now. I can say, like, give me the first two after this node. Sorry. That was wrong. Execute that, and I get the next two nodes. And I can navigate with this. And the cool thing that Facebook built here is that I can slice from both sides. I can say, give me the first two before that node, or give me the last two before or after that node. So I can really slice, and I can use both of them. I can trim from both sides. And that makes this paging very powerful. But I think that's not enough, because maybe I want to filter on my messages. And we have more middlewares for that. So we can say now, okay, paging is cool. Let's use filtering here. And we fetch that. My shape stays now the same because it's the shape change is just to because of the paging. I get a new field that is called where. And where now lets me define in GraphQL, let's break that I can query on my data. And this is done through input types. So basically we generate an input type that has all the possibilities for exploring the data. Like I can say, like, I want the text to be exactly like that. I want the text to contain a special thing. Like, let's say I want the text to contain a B. Then I can, let's get rid of that because it wouldn't work when yeah. So I get bar, buts, and other items, and I can do more complex stuff. Like I could say and then say, okay, let's do an array here of more data shaping. So I have, it should contain that, and you can imagine you can write very complex stuff here. And the good thing is you just did use filtering here, but we actually translate the GraphQL queries that you're writing here into your native database queries. So you're not doing fetching in memory or querying in memory, but in actual database queries. And that is very powerful and reduces a lot of overhead on your systems. And the only thing you have to support is queryable, because we are basically compiling expressions on top of a queryable. And you could do that even with stored procedures if you want to customize it a little bit. Okay, I think I hit the... Okay, my team lead says it's time to drink something. So let's do a little break and then go deeper into it. And get some water.
GraphQL is integrated into it. So for our we had to build a backend system for our fancy UI, and we decided to make a microservice architecture. Thus, this is bringing a lot of benefits like independent deployments, continuous delivery. I think everyone knows it. And we started to build services, independent services, based on our business needs, which will be part of the big schema on the end that UI will use it. So we have services like user, advisor, documents where all the documents for the customer are saved, contracts, and the profile. How Stefan said on the beginning, we had to figure out which is our magic endpoint. On the beginning was a solution with Node.js. We had to write JavaScript code and to create clients for all our services. This was not so friendly for us, and we tried to explore more. At that time, I know GraphQL.net didn't support stitching, and I think now also no. And we built our stitching capabilities in HotChocolate, which will composite all the schemas for all services into one endpoint, which is used by the UI. And I will let Michael to show you what schema stitching is and how to use it.
Okay. what is schema stitching? Actually, it's just the capability to merge multiple GraphQL schemas. And this is crucial because when I showed off GraphQL before, it was all about one endpoint. We have one endpoint from which we fetch all the data we need in one go. So if we were to build microservices, we would have a problem, kind of. Because then we would again have to fetch this GraphQL endpoint, this GraphQL endpoint, and 1,000 others. So there's a concept of schema stitching where I can still, let's go here, where I can still spread my servers. So let's say, and it's not bound to our GraphQL implementation. It's following the specification of GraphQL. So you could have an Apollo GraphQL server here that maybe uses RavenDB or something else. And maybe you have some .NET, so you're using HotChocolate GraphQL or even GraphQL.NET. It doesn't matter. And the really awesome thing, you could also have REST there or OData or something else. And schema stitching will stitch everything together and make one single GraphQL endpoint with which you can query with one query all those endpoints without even knowing about them. And that is super awesome. And there are actually 3 working versions of schema stitching at the moment that are as powerful as HotChocolate. So there's Hazura, which you could use, but then you have to use it with Hazura. Or there's Apollo Federations and our solution. Okay, so how does, I explained that. How does it actually work? So when we get a query into our GraphQL server, we have something called query rewriters. These are basically visitors that rewrite the incoming query to outgoing queries to the microservices. And then they fetch the data from the microservices, wait for the results to appear again, and merge them all together. And this only works because GraphQL is fetching each resolver in parallel. Okay, let's move on. I think the best way to see how powerful schema stitching is to see how it works. So let's have another demo. So let's close that up. Go to demo 5 stitching. Okay, clear. So we need more tabs because we have microservices now. Clear that. Okay. Let's get the config server here. .NET run. I explain it in a minute what each service is. And the customer service here. Okay. This is kind of a Swiss life example. Because we have 2 endpoints, to keep it simple. One is the contracts endpoints, and it serves all the data that you need for your insurance with us, or your BVG pension, or whatever you have here. If you don't have anything, we have some salesman around the corner. And then we have a customer endpoint, and the customer endpoint has all the customer data. It knows about who you are and which consultant you have. Basically, the one that sells you all the stuff that you don't need. Okay, let's see how that works. Let's explore first our microservices. So we have here the customer endpoint, which is on port 5050. And we can do a little exploring. So we can have a look at the schema explorer here and look at the query type. And we see quickly that we have something like a consultant. So we can look up the consultant by ID. And we can look up the customer by ID. Or we could check, we have an ID and we don't know what it is. So we ask for customer, is it a customer or is it an ID? Or is it a consultant? And we'll get whatever it is back. Or we have customers endpoint. So basically, we can explore all the customers that there are. So let's try that first. So we go here, we say, give me a customer, and fetch it. And we get something. So we have a customer, Freddie Freeman, Carol Danvers, and so on. And we can, we can actually go deeper into it. Like we can look at the consultant that is actually selling them their insurance plans. So we have a consultant, Jordan Belfort here, and that's fair enough. We have some data, we can explore it. And we could now take like the ID here of the customer, and we could write another query. Let's do that. This is our query foo. Let's write a query bar. Let's write a query bar and give it and have a look at what the customer is. Look that up. Grab that ID. Okay, this actually has nothing to do with schema stitching. That just has to do with we are exploring our endpoints that we got. Okay, then now I can push execute here and get the data. So the API works very predictable. I like it. Okay, let's have a look at our next API. And that is our contracts API. And we can explore that the same way. We can have a look at the schema, and we will see there is a contract fetcher. So we have a field that can fetch a contract by ID, and we can fetch the contracts for a specific customer. So we need a customer ID. And we explored that before. So we have a customer ID. Let's fetch a contract. Let's fetch the contracts for that specific customer then. So we put that in there. And then we fetch the ID. Oh, that's strange. Just an ID for our contracts. And I did also something wrong. I had to type in here customer ID. And that's awesome. Again, GraphQL protects me from doing anything wrong. I can fire the query, it tells me what is wrong, and I can fix it. So now I have a lot of IDs. I don't know what it is. And contracts, we have different kinds of contracts. So each contract is represented by an interface. And I can now select in GraphQL on the specific contract. Let's say I want to select all the life insurance contracts. I could write here in ... It's called a spread. And I can say every time it's a life insurance contract, give me the premium to that life insurance contract and hit it again. And then I can see I have two life insurance contracts here, and I have one other contract. So I can select the other contract as well and tell it to on. And can tell if it's another contract, give me the expiry date for that contract. So it's kept very simple, just so you don't get lost in the data. Our actual contracts have, I would say, 1 million fields. So let's not go there. And we can also ask the query engine what type it is. So if we had like JavaScript and need a discriminator, we can ask the system to provide that as well. Okay, that is easy to explore, but we have kind of two microservices. And when we showed them our client or UI friends, they said they are ugly. We don't want that. And our client architect, who's called Martin, then told me he wants to do something like this. He said, oh, in the customer portal, I'm logging in as a customer. And this customer is logged in. So I want to be able to write a query like this. I want to write me, which is a customer that is currently logged in. And then he wants to write something like maybe the name. And then he wants to have the contracts here, actually. And then he wants to do all the selection stuff that he can do on the contracts just within the customer type. But that would really mean we have to build a monolith, because now we have to integrate everything together. So then we came up with the idea of schema stitching. And I can show you how it works now. So let's have a look at how that works actually. Go here, say code. Is it right? Yeah. Okay, that are our two microservices. They don't have to be co-located. So in actual, we have them in separate repositories. And then we have something that is called the GraphQL gateway. The gateway is actually the API which the client, the UI developers use to interact with their data. They don't know anything about the microservices themselves. And again, my schema stitching gateway here is a standard .NET, ASP.NET web server. And there's actually nothing special to it except some packages. So I have in here the ASP.NET Core package, and I have a playground package here, but that doesn't matter. We could put it out. It's just so people can explore the API, but by surfing onto the gateway URL. And I have a stitching package, and that actually brings a lot of middlewares that help us to rewrite the queries. So let's see how that works. Again, I have the standard configure services here, but now I use the HTTP factory to tell the server where the other microservices are. And using HTTP factory is very good here because we can use things like poly to make it very resistant. Like when you deploy your stuff, then even in the cloud, sometimes the microservices might be too slow or they are just deploying. So having poly in place there helps you writing a very robust gateway. But that's just as a hint. I won't show you poly here. Okay, we told our server we have there some HTTP client connections, and told the HTTP client connections, the UIs, without any authentication that you would have to solve as well. And now we want to add our schema, but how do we add our schema here? So we have a special helper here that is called add stitch schema. And the stitch schema has actually a stitching builder. We like builders a lot because they make everything very easy to use. Okay, let's do the squiggles. I think we don't need them, but okay. And then we can tell the stitching builder that we want to add a schema here. And we can say, add a schema from file, from HTTP, from string, from wherever you want. And we're doing it from HTTP. You wouldn't do that in real life, because that means when the server goes up, it would fetch the schema and stitch automatically everything together. And you want it to be more predictable. So you can actually push the schema from the domain service to the gateway, or provide it as a file or something else. So you know it's predictable. But this is really cool for debugging. So we say every time my stitching gateway comes up, it should get the customer schema. And since we have a builder, we can just chain. And it should get the schema also from HTTP. And it should get the contract schema. And HotChocolate can do auto stitching here. So let's see how that is, and if our client UI developers are happy with it. Project, just a second, cd gateway .NET watch, because we will change it. Okay, our gateway is now starting, so let's head over to our banana cake pop. We have a lot of funny names for our things, so don't be. Let's take a new tab. Okay, we enter it. We immediately get the schema back, and let's explore the query type which is called query type, which is not what I want. Let's refetch it. No. Okay, what's in cache? So we now have a query, and that query has like our contracts, our consultant, it has our customer, and all these things from the customer service. But now we also have everything from our contract service. And what we could do with just 2 lines of code, we could actually take, let me close them so we have more space. Towers API, we don't need that. We don't need that. We don't need that. Okay. And I think we don't need that. Okay, so I could grab my query that I have here, get all the customers, put it in here, and I could also get this query in here and put it in here, reformat it. Everything is nice and tidy. Let's do it side by side. It's nice. So, and we could fire it up and it would return all the data. So I can now fetch all the data through one endpoint, but it's not what we actually want. So we want to completely rewrite our base types into something new. And let's start with that. So let's go back here. We don't need that. So what we can do is, and we don't want to code it. We just want to tell GraphQL or our gateway here how he should rewrite the schema. So we can do that with GraphQL actually. So let's say add extension from file. We use the file in this case. And our extension file is extensions.graphql. Okay. So now we are loading this extensions files, which is actually empty now. And this allows us to change our schema. So let's do our first change. And GraphQL has a super awesome SDL language. So we can say here extend a type, and let's extend my query type. And I want the query type to have a field me. And that me field is a customer. Okay, that's fair enough. But how should the GraphQL server resolve that? So we have something called that is a directive, and we can say this field is delegated to the customer schema. And we have something that's called a delegation pass. You don't always need it. We can, in many cases, figure it out ourselves. But in this case, we want to remove the arguments from the customer field. So we don't want to just fetch any customer or fetch a customer with an ID. We want to fetch the signed in customer. So to do that, we say, okay, use the customer field from the customer service. And the customer field has an ID. And please fill that up with context data. And let's invent something, user ID. This format. So that means the stitching layer should get some data from the GraphQL context and put it in that field. And that is easy enough. We just have to tell the GraphQL schema, GraphQL gateway where to fetch that data. For this, we have called something that is called a request interceptor. So let's go to request interceptor. And that basically, I copy that in because it's typing that delegate is sometimes tricky. Okay. Okay, that request interceptor actually has 3 arguments. So we have the context, which is the HTTP context. So you have all the information that you have in any ASP.NET middleware. And you have a request builder. The request builder basically allows you to put additional information to that request. You could even rewrite the query here. And then you can define, we just called it user ID, or you can define some context data. In this demo, we use a fixed ID. In real life, you would maybe load it from some scope from your user claims, or you would fetch it from the database or wherever you want it. Okay, so we are set up. It should already have been compiled. Let's refetch our schema and have a look. And we have a me field, which is a customer. So now we don't have to tell the system which customer we actually want. We can just say, I want a customer here, which has this ID, and we can fetch it. And we get the customer that is logged in. But now we want to extend it more, because we want the customer type, this customer here, and this customer there, to have a contract. So everywhere where customer is used, I want to have this contracts field. So let's go back to our server and extend the customer type. So we say extend customer. And then we say, okay, we want to have a field contracts. And it should be an array or a list of something. And let it be a contract. We don't know a contract. And this field should also be delegated. Well, but in this case, let's delegate it to the contract schema. Contract. And use the contracts function that fetches the contracts for a specific customer. So now, instead of getting the data from the context and having always the same ID, we want to get the ID from the customer to which we actually attach. So let's grab the actual customer ID from the instance to which we attach this field. And that's easy enough. We can just say from the fields of the type, we need the ID field and feed that here in. And actually, I remember this is customer ID. Okay. This should already have been recompiled. Let's go back to our UI, refetch the schema, and look at our customer type. So the customer type has now a field contracts, which is a lot of contracts. And I can use here the contracts from the currently logged in user. Again, I would have to write this piece. Let's shift that, play that. And I can access the contracts from this user here, or I want to have it on any user. Let's paste that here. And then I tell you that we actually shouldn't paste this. And then I get, for each user in my list, the correct set of contracts here. And I didn't have to write a lot of code to achieve that. And in GraphQL, you don't have to copy and paste what I just did, like with contracts. You could actually write something called a fragment, which is a reusable query component. Like I could write here a contract. So it's my contract shape on contract, and paste that in here. Sorry. And then instead of copy and pasting always the contracts, I can now just say this is contract. And this lets me like produce reusable query components. Okay, and I get the same result, just more a maintainable query. Okay, that was easy enough, but we can do more. I think we could REST and stuff like that, or OData, or anything else, maybe even sockets. So we can extend it like this and tell it, fetch some nice schema, and it's easy and nice, but I can also inject code here. I can... Okay. I can inject like custom code. Like, let's copy that and I explain it. Let me just paste that here. And just a second, switch over back to our example. So we have different kinds of contracts here. Like we have a life insurance contract and we have some other contract. And this some other contract has an expiry date here. Let's say we want to do some computation on that field and calculate how many days it takes until this contract expires. Okay, this contract is actually expired, but let's build that function anyway. And I can do that with code. I could do that in the GraphQL syntax actually, but I can do that also with code. And this allows me also to use other data sources, even SQL Server in the stitching layer. So what I can do is like, I can do a type extension in GraphQL, but I can do the same with code, which is called an object type extension. You can extend any type. You can extend scalars, you can extend interfaces, whatever you want. You can do it with code, you can do it with GraphQL. And you can give us anything, and the schema builder will actually figure out what you meant. So, and that astonishes many people when they first try out HotChocolate compared to other solutions. They can throw at it actually anything, and we will do something useful with it. So in this instance, we are using object type extension. So we are extending an object type, and we tell the type descriptor our type is called some other contract, what I showed you in the result. And we say we want a new field on that type that is called expires in days. And it should be a non-null int. And we also tell it, and we just tell it because we have dependencies here, we tell it this is a computed field, and it uses a computed directive. And this allows us to specify that we have dependencies on the fields of our type. So each time this field is requested, the server has to request also this hidden field and give us the data. And we just have to ask our resolver context then to give us the actual raw data here. And we can then pick from that raw data that we fetch from the other server the expiry date, ask our context here, actually the type that this data is of, to deserialize it. We will get a date time offset in this case. Then we can do our little computation here, and we have extended that type. So let's add something more here. We add a, I think it's a schema configuration. Yeah. So, and adding a schema configuration is basically accessing the schema builder underneath. So now I'm back where we started. I'm using just the schema builder to extend our actual schema that we are stitching here. So I can say register type and tell it take some other contract extension here, put it in, semicolon. It should compile. Let's see. And now let's explore. We have a new field here, and now we can ask for the expiries in days. So we can tell our query here that we want also the days when our contract expires. My data is a bit outdated, so we get a negative count here. But you can imagine you can just fetch a whole graph from a REST API, and you dump us just the raw data. And you just have to provide us some type information there, and we will actually deserialize and do all the stuff underneath. Okay. So this is basically schema stitching. at the moment we are supporting with schema stitching query and mutation, and we are working on that with the next version that is coming out in January. You can also stitch real-time data. That means you can stitch together subscriptions. It's a bit more complex, but we can do that as well then. Okay, so I have another topic that rounds this talk off, and that is testing your schema. So you have all the nice stuff in there, you have it stitched and it's working nice, but then you need to write tests for it. So how do you write tests for such a dynamic thing like a GraphQL schema? And a colleague of mine at Swiss Life started writing a new tool for that. And that's really helpful. And it's not just for GraphQL, you can use it for anything. Well, let's have a look at it. 6. Okay, so we have a simple X-unit solution here. And since we have something, wie viel Zeit haben wir? Okay, then I have to copy and paste, sorry. Let me paste in the first thing. The first thing that you want to ensure is that you always get a hint if your schema changes. Like, we are inferring a lot of code for you. So, and many users like to infer the schema from C#. But then it's often not very clear to the developer that when he changes a method in C# that you actually add a new argument somewhere, or maybe change the return type from a non-null to a null. And that is breaking for the client. So if we had our schema here and would create it, we could do something like a snapshot on our schema. And the schema actually lets me do a toString and then provides this beautiful GraphQL SDL. And we can run this test. And what Snapshooter does here is basically creating a snapshot. And the JavaScript guys have that for a long time. It's called Jest. And we basically ported that to C# to make GraphQL testing easier. So now I have snapshotted my schema here. And if I were to change, like this is the string type here, we invert it from the resolver because we see this is a constant resolver value here. So it must be a string. But I could now say, okay, but this string is actually a non-null string. String type. And then my schema would change, not my result, but my schema, and that with that my types. And what Snapshooter does now is it tells me your schema has changed actually here. It has a new exclamation mark, so it changed, check that. I can validate my schema, and if I'm happy with it, I just replace my original snapshot and check it back in. But that would be too simple to be a cool tool. So let's have a look at execution tests, and that's actually where it shines. And if you have some old test where you have to test large objects like DTOs, this is really fantastic. So let's add this here. Okay, this is a schema integration test. And this is, if you look at the code base of HotChocolate, you see a lot of those snapshot tests. So we build our schema, we make it executable, and the query executor is actually the thing that the middleware uses to execute the queries. And now we can execute a query here and then do a snapshot directly on the result. We don't have to convert the result to string. We just did it because then we get this beautiful SDL syntax. But in this case, I want to just snapshot the raw object. Oh, that's too much. I didn't want to show that. Okay. So now my field up here is returning always the current time. If I snapshot it, My test goes green because the first snapshot all the time works. I check it. I see, okay, my snapshot looks good. Then I check the code in, and my build server runs it again. But my build server says the time has changed. Well, that's bloody hell, because maybe you have in testing you're using like new like a GUID generation or some time changes. So we can actually do snapshot options here, and we can tell, okay, in this query, just ignore the buts field because that changes all the time. We don't want to have that. And then the same snapshot that just failed will pass because we told the snap shooter to ignore that field. And that is even better because I can not only ignore fields, I can provide custom snapshot options here. I can tell that compare with this and that, or do this and that. And it makes it very easy to write complex tests in a very easy way. And that's important when you start with GraphQL because you have dynamic queries that change a lot and you can do that very easily. So instead of writing hundreds of asserts here, I just have one line. And the pass syntax here is just the JSON pass syntax. So if you had an array, you could just go on and say, okay, the first item, blah, blah, blah. Okay. I think that's it to that. Let's head over to my slides. Let me give you a little outlook on our open source project. So at the moment, we have HotChocolate version 10 with schema stitching, automatic database filters, and actually the GraphQL core server. And it's the fastest GraphQL server on the .NET platform. It only consumes a fraction of what GraphQL.NET does. And it executes up to 13 times faster than any other GraphQL.NET framework tool. And we are currently working on version 11, which brings in the GraphQL client Strawberry Shake, which specifically supports Blazor and Xamarin, and it works even on your Apple Watch. And also you saw this tooling that I use here. We will release it as well. We're still getting some kinks out. But where it really comes all together is then in August next year, where we have the full suite with a schema registry, where we have change tracking and all this change tests that you saw you don't need anymore because we will tell you that you actually break with this change the schema. And also we have automatic database mapping. Like today we can filter on databases that you provide us, but then you can say, okay, I have this database here, and we make you a schema from it that works completely from top to bottom. And that also works the other way around. You can just write a GraphQL SDL syntax, and then we make you the database of that. And it's needless to say that you can stitch that together with our gateway that we already have with whatever you want. Okay, that's from this part. And then I want to make an invitation, like everybody who likes to do open source here, Swiss Life, and also we love open source. And I think not a lot of people think of Swiss Life as an open source company, but actually the team that is doing the face to the customer services are heavily invested in open source. We have like not only the snap shooter, which is a small tool, but the team has built something called Squadron, which is a container testing framework where all of you that are testing with cloud services should check out Squadron, because you can do like test against a Mongo database or any other services, and we will just put the service up without you even knowing for just your unit test. Check it out. It's too complex to explain, but it's so easy to use. And also not only use it, if you want to contribute to it. And especially with HotChocolate, we have a lot of newcomers that did their first commit with us. Just yesterday, there was a Russian girl that committed some database optimizations for our queries in Oracle. And I first had to, I think I had to read her code 3 times to actually understand that it really does do a performance improvement from a special query that ran like 1 minute and now it runs in 8 seconds. But those first time contributors, we will help you along. And we are not judging anybody for even suggesting a bad idea. I think it's important to get people aboard and help them along instead of judging. Okay. Does anybody has questions?
I do.
Okay.
Will you send me the slides so we can publish them?
Oh, yes. You will see in a minute.
Great.
Anybody else?
Yes. All this you have shown is completely for free.
It's for free. We don't take a penny. It's all open source. And that's what I mean. We are heavily invested in open source and love open source. So you can grab it and use it.
That's amazing.
Yeah.
I don't know any of you here who is excited. I am excited. I'm excited.
Yeah.
These examples which you show in the presentations, are they on your website so that we can?
Yeah, we actually have a lot of documentation, and if you use the other GraphQL frameworks in .NET, you will be very disappointed about documentation. I mean, you can always provide more, but we have a lot. I can show that later. Yeah, but we have a lot of documentation. Just head to HotChocolate.io. We have a slide where you have a QR code, and this leads to a repository on GitHub where we have the slides that you saw today, all the examples, just in working form. So I copy-pasted everything in, so they work from just booting up, and links to the documentation. And we have a very active community. There are coming new people every day to our Slack channel, and I think we are committed to answer each question in about, I would say, if you write something, then it takes maybe six hours to get an answer. And that is, I think, important, because in many open source projects that I ran to, it was like you post a question, and then you wait like a week or two, and maybe you get an answer. But we are very committed to answer your questions. So if you get in touch with us, we will help you along. That's actually so the QR code will lead you to the repository where you get all the information on the repository, or you can just surf to our links directly. Yes? Sorry.
For the gateway you showed, there was a lot of coupling between the ASP.NET API and potentially some business logic. How would you design this, architecture this, in a way that it's
you don't have to couple it this way, and actually that's what I said in the beginning. I wouldn't do it like I did it in the demo, and we are not doing it like in the demo, because what I showed in the demo was more the showing off the capabilities that you could do in a time frame that is possible. Actually, it's good to you can do two things. Either you export your schemas on build time and then integrate them on deployment. That's actually a good thing, because then you break on build, and not like the gateway now. If I updated one of the domain services and they had an issue when they come up, we couldn't stitch anymore, and the gateway would be dead. But if you stitch on build time, then there would always be a working version of the schema, because you ran through the build, and on build we did a pre-stitch and ensured that you are working. So, and the business logic you would keep in your domain services. But you could write adapters, like that I said for REST. You could write a little adapter, which is perfectly okay, because it's kind of an infrastructure object, and that you could inject there and tell, okay, there's a Swagger schema, let's read it and infer the actual GraphQL schema from it. We have that on our list to have like add Swagger schema, but we have so many things on our list.
I mean, it's amazing to have all this data in one place, but how does it work with access control?
Oh yeah, actually, like we tried this talk out yesterday. I had a lot more things in here, like cost control. Like now you could fire against your schema like huge queries, but maybe you don't want that. Maybe you want to have like certain users have a certain amount of costs that they can do, and each field has a cost or a value. We have that out of the box, and also authorization is out of the box. We inject basically authorization policies there, and you can easily add them to your fields. And you can do the authorization in your domain services, or you can do them on the gateway. It's up to you how you want to do that. I can just, let me head over here. We have really we started with a crap documentation, but I think we now have quite a good one. But there's still not everything in the documentation. It's very time consuming. So we have a lot here, like authorization, for instance. Let's go here. And how that works is you can say to a field, and again, this works, that's not good readable, but what, zoom that in. Can you see that? So I can tell a field, this field is authorized. And then we would do a standard authorized check on that field. That's simple enough, but you could also authorize a type, or like this is an example with the SDL, because we can do both. I just showed code first, but you could also do SDL first with HotChocolate. Here you had something like where I said authorize this field, and use the roles foo and bar. This is the old style like in ASP.NET Classic. Or we have something that is called policies. That's down here. And there you can say use the sales department policy to authorize. And then you're basically hooking up the new policy API from ASP.NET Core. And there you can write awesome policies. And that makes it very easy to test your service, because you can now swap those policies out in your testing and test the actual policies separate from your business logic. Oh, sorry. And there's more, like what I said before. There's thousands things like security. Like this is actually the query depth problem that I told you. You can limit queries for depth, or you can have cost analysis on. You can give fields cost. You can give them dynamic cost, where you say, okay, actually, if we have paging, then the first that you saw, so the argument that tells the resolver to fetch this amount of data is actually a multiplier for cost. So we have very complex things there for operations. And there is a company that is called PushPay in New Zealand. They are actually contributing a lot of those operation things, because they just went live with HotChocolate.
I think Michael could talk until midnight of
Yeah.
GraphQL, but I think we can have some cool things. You can still ask him some question or contact us by this slide. Maybe you can show this
Yeah.
slide again.
Again, there. Yeah, head over to our Slack channel. I'm happy to talk to you, and there are other things. There are also contributors today here. There's Pascal, he did the filters actually, and they are working in a company called Gia. Did I say that right? And he does a lot of work there, so it's really an open source project where many people contribute and use.